next thing is the sum and difference rule. So all that really means is that if you have two functions that are added or subtracted, then when you take the derivative, you literally just take the derivative of one and then you add or subtract whichever one it was before that with the derivative of the other guy. So that works especially well with polynomials where you have separate terms that are added and subtracted. You just take the derivative of one and then put a plus or a minus and then take the derivative of the next one and move on with your life. So number one, f of x equals x cubed plus x squared minus 2. Okay, we don't have to do anything with this function. It is perfect as it is. So there's no like crazy exponents or negative exponents, no square roots, nothing dumb. So let's take the derivative. F prime of x equals x cubed, that 3 is going to come out in front, then the x, and then take 1 away from that 3, making it a 2. Plus sign next, x squared becomes 2x. These guys show up like all the time. So get in the habit of x cubed has a derivative of 3x squared and x squared has a derivative of 2x. They show up constantly. Speaking of constants, negative 2 is next and the derivative of a constant is 0. So you can put plus 0 if you want, but then you really want to simplify it out to just 3x squared plus 2x. Okay, we don't really want that hanging out on the end. Next, number 2. We do have a weird thing going on with 1 over x. This is another one that shows up all of the time. Notice that I had f of x and it is still f of x because we have not taken a derivative yet. So I am just copying in order to rewrite that last term. Okay, 1 over x is the same thing as 1 over x to the first power. So keeping the 1 coefficient, or making it invisible actually, I'm going to have x to the, it was on the bottom, so it's a negative power, and then you just copy the number, so x to the negative 1. Okay, the derivative, f prime of x equals, multiply, 5 times 3 is 15, x to the 5 minus 1 is 4, minus 3 times 2 is 6, x to the 3 minus 1 is 2. Now you would normally put a plus, however, there's an invisible 1 there. Negative 1 times positive 1 is negative 1. X to the negative 1 minus 1 is negative 2. Now, I am perfectly fine with you leaving it there, but just for the extra practice with the negative exponents, because you probably haven't dealt with them in a while. Copy down everything else except minus. Then you're going to make a fraction because you had a negative exponent. Push that x and the 2 down to the bottom of the fraction, making a positive exponent in the denominator. Whatever the coefficient was, it's going to go on the top. So you could put plus and then have a negative 1 here, or you can just put a minus there and call it good. So either one of these answers is acceptable depending on if it says you are allowed to have negative exponents or not. The last little bit of our first derivative page is sine and cosine functions. These guys show up constantly as well, but they are not constants. That joke is completely over. All right, so we are taking the derivative, d dx. Remember that means the same thing as like f prime of x. We want to take the derivative of, and then this is f of x. Okay, the derivative of sine of x is cosine of x. You cannot just put cosine, you got to put the x there as well. Then over here, we have the derivative with respect to x of cosine of x, and it's really similar, except it is going to be negative sine of x. Okay, so sine of x has a derivative of positive cosine. Cosine has a derivative of negative sine. Okay, we've got a couple examples here, well, 3 examples. So number 1, f of x equals 2 sine of x. That's the same thing as 2 times the sine of x. So f prime of x is going to be 2 times whatever the derivative of sine of x is. Derivative of sine is cosine, so 2 times cosine x. And we are done. Number 2 is really, really similar to number 1. If this is f of x, then f prime of x equals, this is 1/2 times sine x, so its derivative is 1/2 times Derivative of sine of x is cosine x. Okay. So this works where you can just like copy down the coefficient and then take the derivative of your function, because the 2 and the 1/2 over in this case are constant numbers. There's no x over here that's multiplied times the sine of x. In a future lesson, we'll do problems where there's like a function times another function, and they do not work the same way. That'll be a different rule that you have to learn. Number 3, we've got f of x equals x plus cosine x. All right, so there's a plus in between. So just like when we were doing polynomials up here, we take the derivative of each term separately. If you need to cover up one term while you're taking the derivative of the other, that is totally fine. So f prime of x equals the derivative of x. Let's kind of zoom in on that one for a second. X is the same thing as 1x to the first power. When we take derivatives, we multiply the exponent times the coefficient and bring it down. That's a 1. And then you subtract 1 from the exponent, and that becomes a 0. X to the 0 power is 1. So the derivative of x is literally just 1. Another way to think about that is, what is the slope of y equals x? The slope of y equals x is 1, and there it is. Okay, next, plus cosine x. I'm not going to write the plus because the derivative of cosine of x is negative sine of x. Okay, horizontal tangent lines. Ooh, okay, these guys are another like big idea within calculus. Horizontal tangent lines mean that your line looks like this, right? Horizontal is like the horizon, like the sun rises over the horizon. Horizontal tangent lines have many applications in calculus. You can find where a function has a horizontal tangent line by taking the derivative and doing something. So let's think about this. If a derivative means slope, what is the slope of a horizontal line? 0, right? M equals 0 for horizontal lines. So really all you have to do is say f prime of x equals 0. So generally you have to take the derivative, like find f prime of x. And then whatever that equation is, you're going to put equals 0, and then you solve for x. So back up here to the actual notes, you can find where a function has a horizontal tangent line by taking the derivative of the function and setting it equal to 0. And then solve for x. Right? Every single place where your function equals 0, there will be a horizontal tangent line. So let's look at that for problems 1 and 2. At what values of x do the following functions have horizontal tangent lines? So let's find the derivative. So f prime of x equals 2 times 3 is 6. X to the 2 minus 1 is 1. Minus, that's an x to the first, so 1 times 2 is 2. X to the 0 power, so that disappears. And then you could put a plus 0, but there's not really a point to that. Okay, so our first derivative, f prime of x equals 6x minus 2. All right, that's not so bad. Well, the question is, where does the function have a horizontal tangent line? Horizontal tangent lines happen where slope equals 0. So you can put that equals 0 over here or over here. It doesn't really matter. But then you just solve for x. So we're going to add 2 to both sides. 6x equals 2. And then divide both sides by 6 and get x equals 1/3. So at x equals 1/3, you would have a horizontal tangent line for f of x. Number 2, f of x equals negative cosine of x. That is the same thing as f of x equals negative 1 times the cosine of x. That's important because if you remember, cosine of x has a derivative of negative sine of x. So f prime of x here, the derivative, equals -1 times the derivative of cosine of x, which is negative sine of x. Simplifying that out, f prime of x equals positive sine of x. Okay, we want to know, where does our function have a horizontal tangent line, at what x values? So we set sine of x, our derivative, equal to 0, and we solve. Now there's a few different ways to think about this. You can take sine inverses of both sides, like arc sine of sine x, and you end up with x equals some numbers. But I think it's easier to graph sine and take a look at it that way. Remember that sine of x starts at 0, 0, and comes along like this, and then it repeats itself over and over, right? That's sine of x. Okay, we want to know, where does this equal 0? So sine of x equals 0 here, and here, and here, and again, over and over. So this happens at 0, at pi, at 2 pi, and so on. So you can write that over here in several ways: 0, pi, 2 pi, and so on. There's a way you probably wrote it in your trig class / honors pre-calc, whatever you took, I don't care. It would have been like pi times n, where n is a constant number, right? So those mean the same thing. Of course, it goes backwards as well, so negative pi would also work. Negative pi, negative 2 pi, and so on. So lots and lots of values here. All right, we are going to do one more thing about sine and cosine functions. So you might have noticed that sine of x has a derivative of cosine, and then cosine has a derivative of negative sine, and then negative cosine has a derivative of sine. Okay, so I wonder if we could make a pattern out of this. So I'm just going to go in this box, just like off on the right. I'm going to do 4 different things right here. I'm going to start with sine of x. The derivative of sine of x is cosine x. We already talked about that one. The derivative of cosine x is negative sine of x. So if you take the derivative of -1 times the sine of x, that's going to be -1 times the derivative of sine x, which is negative cosine of x. And then we talked about how negative cosine has a derivative of sine of x. So this is a pattern that repeats itself. So you take derivatives down. I'm going to put d dx. So you take derivatives straight down. Sine's derivative is cosine, cosine's derivative is negative sine, negative sine's derivative is negative cosine, and then negative cosine's derivative is sine again. So this will come in super duper handy if you can get that memorized. Hey guys, today we're going to do 2.2 for calculus, which is basic differentiation rules. Differentiation means taking a derivative, taking or finding a derivative. Okay, if there is anything that you remember from calculus, like way later down the road, like 20 years from now, it is going to be what we are learning today. Like, you probably won't remember all of the little limit rules, and that's fine. But finding a derivative, you're going to be like, oh yeah, I totally know how to do that thing. Okay, so these are the things we're going to accomplish today. We're going to find the derivative of a function using the constant rule, using the power rule, and then find the derivatives of sine and cosine functions. So we're doing the shortcuts today. Derivative, constant rule, and power rule. The derivative of a constant number is 0. This is because the graph of a constant is a horizontal line and the slope of a constant is 0. You're just done. Okay, so if f of x equals 7, then f prime of x, the slope is 0. And what's really nice about those is if you have one term that is a constant, then the derivative of that one term is going to be 0. So that applies even if there's a bunch of terms all added and subtracted together. The next thing is the derivative of a function with x raised to a power. So n is going to be some number. It's going to be like a 3 or a 7 or a 1/2 even. Okay, f prime of x is going to be n times x to the n minus 1 power. Now that sounds a little intense, but I promise that this is going to be the thing that you remember. What you do is you take whatever the exponent is and you multiply it times whatever the coefficient of x was. So you just like bring it down in front and multiply. You keep the x, and then you take whatever your exponent was and just decrease it by 1. Subtract 1. Let's do some examples. Example 1 is f of x equals x to the 5th power. To show the next line, you have to put f prime of x to show that you have taken a derivative. If you just put equals, that is going to be incorrect. You've got to say that it's the slope, the derivative. Okay, we're going to take x to the 5th, take the 5 down to the front, copy down the x, and then bring that 5 down by 1 to become a 4. Done. Remember how much time that took with the limits? Lots of work. Next one, f of x equals 1 over x squared. Now that does not quite look like x raised to a power, so let's see if we can write it differently. What is a different way that we can write a power that's in a denominator? Well, we can write it as a power that's in the numerator by just putting a negative sign in front of that power. So 1 over x squared is the same thing as x to the negative 2 power. That's an Algebra 1 property of exponents that you learned. Okay, so that is still f of x. We have not taken the derivative yet. So when we take the derivative, it becomes f prime of x, and that's going to equal, use that same rule. Negative 2 comes down in the front, put in x, and then subtract 1 from the exponent. Okay, so negative 2, if you subtract 1 from that, you end up with negative 3, not negative 1. So you got to be careful on that. Now the problem might let you just leave it like this. However, sometimes it's better to write it when you, oh my gosh, instead of having negative exponents, you want to write them with positive exponents. So you're going to do the reverse of this power rule. So f prime of x is going to become negative 2 over x to the positive 3 power. So the coefficient just stays on top. The x and its exponent move to the other part of the fraction and become the opposites. Probably want to see that. The negative 3 becomes positive when you move that x down to the denominator. Last one on this row, f of x equals the cube root of x squared. We want to write radicals instead of writing it in radical form, write it in exponent form. That is another Algebra 1 concept, so let's do it. F of x is going to equal, okay, whatever the base is. The base was the x. The power was a 2, so it's like x squared, but this has a radical of a 3. So the cube root, you can really just take that little 3 and make it as like a denominator for the exponent. I'm going to review that here in a second, but let's go ahead and take that derivative. So this is the same thing. It's equal to this. We have not taken the derivative yet. Now let's take a derivative. F prime of x equals. Okay, our rule says that we take the exponent and bring it down in front, 2/3. You keep the x, and then you subtract 1 from whatever your exponent is. Now 2/3 minus 1 is the same thing as 2/3 minus 3/3, which is negative 1/3. Okay, if we were to use the negative exponent rule, that property from before, we could rewrite this. We're rewriting, so we copy the left side as 2 over 3 times x to the positive 1/3. So now we have a positive exponent instead of a negative exponent, but it's in the other part of the fraction. Okay, what if it asks you to write it in radical form? So we're doing a rewrite again, keep the left, equals 2 over 3. Fraction exponents are radicals, so I'm going to write a radical. The base is still the base. The exponent on top is still the exponent, so x to the first power is just like x, but you can write the 1 if you want. And then the denominator from that exponent becomes the root for the radical. It's also called an index. Okay. Here's a little reminder of how to do that from Algebra 1. Like, what the heck is that? Okay, let's say that we have a nice pretty picture of a tree. I know, we're getting all elementary, drawing some pictures here. So we've got a tree, and then up above we have the sun. Okay. The tree at the very bottom of it has roots. And the sun up above has power. So when you are looking at a fraction exponent, the power is at the top and the root is down below. So that root is here and the power is here. Go ahead and put some x's in there. So it's like x to the power over root. That's the same thing as x to the power, and then it's inside of a root. There's one other way to write that. It's x to the nothing. So we keep a root here. And then you put parentheses around that whole thing, and then you put the power on the outside. I like this way a lot because you can simplify your x and then take it to a power, which makes it small before it gets big. But these are all things that you do need to have figured out. You need to be able to go from one form to the other really fluently. The next little bit on this page is the constant multiple rule. Okay, constant multiple means a constant that is multiplied. That is also called a coefficient. So let's say that f is a differentiable function. That means you can take a derivative of it. And c is a real number, so some kind of a constant number. Then c times f is also differentiable. You can also take the derivative of c times f. So remember up in problem 1, we just had like an x to the 5th power. But what if it was like 2x to the 5th power? You can also take the derivative of that. That's all that means. Okay. So problem 1 down here, this is a power rule. It's a power rule because x is to a power. So when we take a derivative, f prime of x is going to equal, well, hang on here. Previously, we had just that exponent and we would just bring it down in front. So the derivative of x squared is just 2x to the, subtract 1 from 2, first power, 2x to the first power. But there's a 3 in the front. So what you will do with this is multiply whatever your exponent is times the coefficient as you bring it down. So 2 times 3 is 6 times x to the 2 minus 1 is 1, so just 6x. Number 2, we have f of x equals 2 over x. X is in the denominator, which means that that is the same thing as 2x to the negative 1 power. I have not taken a derivative yet because there's no prime right there. So f prime of x, we can take the derivative now, is multiply your exponent times your coefficient, negative 2, x to the negative 1 becomes negative 2, right, as you subtract 1 from it. And then if we are asked to do a rewrite on this, f prime of x equals, keep your coefficient on the top over x to the, and then negative 2 becomes positive 2 as you bring that down. For me, either one of these is an acceptable answer. It is very likely that a textbook would give this as the final answer. Multiple choice would give this as the final answer. but this means the same thing. So if you have a free response question, you can totally leave it like this, no big deal. Sometimes it's easier to solve problems though, if you can see where the x's are. So sometimes it's kind of nicer to see it in that last form. Okay, last one in this row, f of x equals 3 times the 5th root of x cubed. Let's rewrite f of x, so we're not taking a derivative yet. This is 3x to the. Okay, so 3 was the power. Power is the sun on top. 5 is the root. Trees' roots are below the ground. There it is. I know that's super dorky, but whatever. Okay, so f prime of x equals, let's multiply. 3 times 3/5 is 9/5. X to the 3/5 minus 1 is -2/5. And again, I personally don't care if you leave it like this as long as it's a free response question. But let's get some practice with moving some stuff around. So f prime of x equals 9/5, right? So you keep the coefficient on the top, the bottom stays on the bottom. Negative exponent moves to the bottom, so x to the positive 2/5. And then if you're asked to put it back in radical form, you really just take the 5 and move it out as the root. So it's 9/5, that 5, times the 5th root of, so that 5 is here, x squared. The power stays the power. Any of these is a valid answer. Just make sure that you're actually answering what the problem is asking you.